Hello, my name is Hunter Sanford,
I am Manfredo Marroquin.
Hi, I'm Pierre-Alain Gbalou.
and this is our project on phase diagrams.
So in our first question, we asked to give the phase diagram of our two metals and also one with the alloy, when they form an alloy. So first, we have the phase diagram of the pure iron. So we have the temperature in Celsius on the y-axis and the pressure on the x-axis. So as you can see, there are different states. This is when pure iron is in vapor states and liquid. We also have different type of iron. So we have the alpha iron, which is BCC. We have the gamma iron, which is FCC, and it's at a temperature of 9-10 degrees Celsius. And here we have the delta iron. We have the delta iron, which is also BCC, and we see that at the temperature of 1394 degrees Celsius. So here we have the phase diagram of nickel, but because we couldn't just find pure nickel, it was very hard to find. So we have the phase diagram of nickel with molybdenum, but the molybdenum here is in only a small quantity, so we went with our phase diagram. So as you can see, we still have the temperature in degrees Celsius on the y-axis and the weight percent of nickel on the x-axis. So here. So now this is the phase diagram of our alloy. When iron and nickel form an alloy, it becomes invar. So we have the phase diagram of invar here. Still the temperature in degrees Celsius and the weight percent of nickel in the material. Here we can see that our material is in magnetic transition as shown in these different figures. So we still have different type of alloy, like we have the gamma type here, we have the delta type here as shown on the diagram, and we have the alpha type. We have the alpha type iron here.
All right, so when we talk about the crystal formations, we're really talking about how the liquid sort of solidifies into those crystals. The primary way that we've seen that done is with this eutectic reaction. So when we see this liquid line right here, we're going to find where it sort of bottoms out, because that's the point where it's going to go from pure liquid to pure solid. You can see over here there's a gap where it would fit this delta iron plus liquid region. So instead we look for this just liquid to straight gamma iron plus nickel. That's our eutectic reaction. And then on either side of that, you have similar solids. On the left side, you have a hypereutectic composition, and on the right, a hyper. That'll be shown later with the lever rule, but there it is out on the graph. And then the other sort of thing to point out on this graph is the phases that the iron takes as it moves throughout the temperature range. So up top, you can see that this is still the gamma iron plus nickel range, but as it cools down, we hit an alpha iron range. That shows the allotropy, so we can see that iron will still change even though it's still in solid form.
So we're going to be talking about tie lines in the phase diagram. A tie line really is just a isothermal line, or a constant temperature line that we draw on the diagram from one part of the phase to another, and it ends at intersecting points of like solubility curve. So in this point, alpha right here, and then the liquid phase over here. And really all a tie line does just shows the composition of the two phases in equilibrium with one another. So if you want to find the composition or percentage composition of alpha and liquid, we do it via tie lines, and that's where the lever rule comes into play. So when we have C naught, which is the composition that we want to ratio that we want to find, we would do the following: C naught is equal to the ratio of alpha multiplied by the composition of alpha plus 1 minus the ratio of alpha multiplied by composition of the liquid phase. And if we do some rearranging, we get C naught minus C liquid is equal to the ratio of alpha multiplied by composition alpha minus composition of liquid, and more rearranging, we get the ratio of alpha is equal to composition naught minus composition of liquid all over composition alpha minus the composition of the liquid. And composition naught would typically be a percentage, like in this case it's abstract, but it'd be like 65% or whatever, and you would find composition alpha and liquid via tie lines, and then from there it's just simply plug and play, and that's it. Thank you for watching our video about Project 5. My name is Manfredo Marroquin.
My name is Pierre-Alain Gbalou.
And I'm Hunter Sanford.
And thank you.